Check, 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 check. Check, check. Um, in this session, I want to configure Boson courseware 101.1 ICND1 Module 6 Network Security Basis. It's on Basic Network Security branch. Check. The title of this lab is Type 6.1 Basic Network Security. So this lab corresponds to ICND1 Module 6. And here's all the topology. We have 3 routers, connects to serial 00 for each interface. This message is okay. It can be used to display message to user attempts. Is all the IP address table that were given to us. Okay. Configure basic for R1. Download this. On router 1, configure enable password of Boson and enable secret password Cisco. Enable password and enable secret. Test it. So on router 1, we type enable, configure the terminal, enable Boson, enable password of Cisco. We go into task number 2. Test the password you configure by exiting privilege exact mode and then entering it again. What do you observe about the enable password and the enable secret password? Exit, enable, exit, enable. Okay. User exact privileges. This one. Cisco. Secret Cisco. Enable config, enable secret Cisco, enable password Boson, exit, enable Boson Cisco. Okay. The enable secret password command is more powerful than enable password command. So the safe password is the enable secret or Cisco. Configure password of ICND lab for other one's console port and enable password check-in at log console port. Line console check conf d and console to password ICND lab. Test the password you configure by logging out of the router and then logging back in. What do you observe about the different passwords? Log out. Zip. Cisco ICND lab. Okay. What if I configure the password from another enable secret? Again, is it safe, different, or by that time you configure that configuration? So we're gonna set enable CND lab. Stop Cisco. Yeah. Password that we configure on line console 0 command is set on user exec mode. Different than the enable secret command set on if we like privilege exec mode. Uh, um, uh, uh. Issue the show running config command to view the passwords to configure under one, which of the password is stored in plain text. Show run. Boson. Cisco. Show run. Enable. Plain text. Boson. Enable password. Enable password encryption for all passwords on RAR1. Enable password encryption for all passwords on RAR1. Enable. I don't know when to start to show you the shape of my heart. Service and config service password encryption do show run. Okay, all of the password that we configure on RAR1 is already encrypted because we type the command service password encryption on the global config mode. Verify that the passwords on RAR1 are encrypted. Okay, verify it with the show running config command. On its VTY lines, configure RAR1 to accept remote access connections and to accept connections that only use Telnet protocol. Use the password of Boson Lab. Line VTY 0 to 4. Password Boson Lab login transport input telnet. Issue designing show running config command to ensure that R1 is correctly configured for remote access. R1 for remote access. Please show run that configuration, and the password is already encrypted too, because we already configured the service password encryption earlier. And the transfer input is only telnet service. Log on to the console of router 2 and access router 1, console of router 2 and access router 1 remotely using a telnet protocol. After verified connectivity, close the telnet session. Okay, what is the router 2? Enable telnet 192.168.2.1 password Boson. Okay, exit. Configure login banner and MOTD banner on router 1. Banners are used to display information about devices or to display security messages. On router 1, create the username, my name, and assign the user a password of Cisco. How is the password that you just created for the user my name stored? Go check, go to configure terminal. Username, my name, and password Cisco. Show run, do show run. It is stored on username and password stored and the run and config. On router 1, enable password checking when router 1's console is accessed by a user. Enable password checking router 1's console. Under one, you should issue the following commands to configure the device to use its local database for authentication at login. Local database. Ini apa? Line console hero. Login local passage. When is the banner configured with the banner login command display? Banner login. The following banner is the login banner on the one. Use as the limit. Susah juga ini. Once the banner configured with the banner logging command displayed, it is displayed when um, is displayed when the user login. After each device is used to route traffic between departments. Log out of the console for router 1, then log back in to view the login banner on router 1. Exit, exit. Bisa. Configuration. Configure basic security and banners for router 2 and router 3. Use the commands you learned during the previous task in this lab. Configure unenable password of Boson and enable secret password of Cisco. Okay. Um, Username. Ada username sih. Enable password Boson. Enable secret Cisco. Configure password of ICND lab for both devices. Console ports. Line console 0. Password ICND lab. Login. Enable password encryption for all passwords. Service. Service. Password encryption. Under VTY lines, configure both devices to accept remote access connections and to accept connections that only use Telnet protocol. Use the password of Boson line line VTY 04 password Boson transport input Telnet login exit create the username my name and assign the user a password of Cisco. Username my name password Cisco. Enable username and password checking when the consoles are accessed by a user. Line console 0. Login local. Configure the following banner as the login banner. Hit banner login. This device is used to route traffic between departments. Banner and OTD. You must be an authorized user to access this device. Bisa. Then OTP. Benar, OTP. You must be an authorized user to access this device. Run, use run. Exit. Login bannernya. Cisco. Enable county, enable password Boson, and enable secret Cisco. Both devices console. Both check both devices console ports. Both device okay. Line line console 0. Password ICN11. Agent but service password encryption. line 50y04 and password Boson web transport input telnet login exit username my name password Cisco line console 0 login Prog exit panel login is device is to route traffic between departments. Banner MOTD you must be an authorized user to access this device. Choose your run. Exit, log out. My name is Cisco. Enable Cisco. Config. Exit, log out. Okay. Do My name is enable Cisco config banner MOTP no you must be an authorized user to access this device. Banner MOTP
Guess how far it is from my house? Guess.
Our two highest level characters that have died over the past few years in Hardcore Warcraft. We've resurrected them on the original home of the hardcore movement, Bloodsail Buccaneers, before Blizzard gave us official servers. Our goal is to hit level 60 without dying a second time, and to do it by the time Sam Solo levels up in real life to 7. His birthday is on July 8th, and we're gonna try to hit 70 before then. I mean, man, guys, we're all messed up. July 8th, we're gonna try to hit 60 by July 8th to give him his first level 60. That was really confusing. I'm sorry. I hope it kind of made sense. Epic Light was my very first level 55 in Hardcore WoW. She died.
Here in my heart, there's a picture of us together forever, fading and unbroken. Wherever you are, your covers me.
List. Practice quizzes covering the material in each lecture, flashcards to help you review and remember what you learned, practice labs using Cisco's network simulation software Packet Tracer, and at the end, multiple practice exams to get you ready for the real thing. Although this course will be based on Cisco's official exam topics list, I also want to give you extra information to improve your understanding of networks in general. That additional context should also help you understand the exam topics. Because this is the first video in the series, I want to talk about This is a free, complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help you videos. Thanks for your help. In this video, we will look at another topic, Ether Channel. Ether Channel allows you to connect multiple physical interfaces into a group which operates as a single logical interface, so they behave as if they are a single interface. There are many benefits to this, and I'll explain them in this video. By the way, this video covers of the official free Ether channel using a protocol called aggregation control protocol. So what will we cover in this video? First off, I'll show you what Ether channel is and what problems it solves. Here's a hint. Spanning tree protocol is the big problem. We will also look at multiple methods of configuring both layer 2 and layer 3 Ether channels. A layer 2 Ether channel is a group of switchboards which operate as a single interface, and a layer 3 Ether channel is a group of routing ports which operate as a single interface. watch until the end of the video for a bonus question from Boson Software's Netsim, the best practices used for the CCNA. I used Boson Netsim to prepare my CCNA and CCNP exams, and it was a that allowed me to pass all of my exams. Okay, let's get started with the video. So let me demonstrate a problem. We have two switches here, A switch 1 and D switch 1. I will talk about basic network design later in the course, but A switch stands for access switch, which is a switch that end hosts like PCs and servers connect to. D switch stands for distribution layer switch, which is a switch that access layer switches connect to. For this demo, let's say there are many end hosts connected to A switch 1, let's say 40 hosts, and they are all trying to access the internet to do their work. The network administrator notices that the connection to D switch 1 is congested, so he decides that he should add another link to increase the bandwidth, so it can support all of the end hosts. Hosts connected to A switch 1, let's say 40 hosts, and they are all trying to access the internet to do their work. The network administrator notices that the connection to D switch 1 is congested, so he decides that he should add another link to increase the bandwidth, so it can support all of the end hosts. So the network admin adds another link and monitors the situation. However, the additional link doesn't seem to help. The connection between A switch 1 and D switch 1 is still congested, and end users are reporting problems. So the admin decides to add another link between A switch 1 and D switch 1. He adds another link to the connection between A switch 1 and D switch 1. Surely, this will be sufficient. The total bandwidth of the connections to the end hosts is still greater than the bandwidth of the connection to D switch 1, but that's okay. All hosts in the network aren't always in a constant state of sending and receiving internet traffic. I will talk more about this later in the course, but when the bandwidth of the interfaces connected to end hosts is greater than the bandwidth of the connection to the distribution switches, this is called oversubscription. Some oversubscription is acceptable, but too much will cause congestion. However, even with 3 links to D switch 1, the congestion doesn't seem any better. So the network admin once again decides to add another link between A switch 1 and D switch 1. So now there are 4 links between A switch 1 and D switch 1. Do you think things have improved? Well, they haven't. The connection between the two switches is just as congested as before. Why is this? You should be able to figure out the answer. Here's a hint. Think about what you just studied in days 20, 21, and 22 of this course. If you know the answer, well done. If not, don't worry about it. You will now. Let's say the administrator went to physically look at the port lights of the two switches. What color do you think they were? Well, the network admin checks D switch 1 and all of the port lights are green, so there doesn't seem to be a problem. However, when he checks A switch 1, he notices that of the links connected to D switch 1, only one light is green and the others are orange. Why is that? It's because of what we studied in the past few days of this course, spanning tree protocol. If you connect two switches together with multiple links, all except one will be disabled by spanning tree. Why does it do this? Well, if all of A switch 1's interfaces were forwarding, layer 2 loops would form between A switch 1 and D switch 1, leading to broadcast storms. Other links will be unused unless the active link fails. In that case, one of the inactive links will start forwarding. So, although having backup links is a good thing, because failures can occur for various reasons, it's a waste of bandwidth to have these three interfaces disabled, not forwarding any traffic. However, by forming these four physical interfaces into one logical interface, Ether channel can solve this problem, giving us both redundancy and increased bandwidth. An Ether channel is represented in network diagrams by drawing a circle around the interfaces that are grouped together, like this. Ether channel groups multiple interfaces together to act as a single interface. STP will treat this group as a single interface. So after grouping these interfaces into an Ether channel, the network admin once again checks the link lights. This time they are all green. Won't this cause a layer 2 loop? Actually, no, because this group of 4 links behaves as if it is a single link. For example, let's say a PC sends a broadcast frame. So it has flooded out all interfaces on A switch 1. All of the PCs connected to A switch 1 will receive a copy of the frame. Now, how many copies of the frame will D switch 1 receive? Remember, although there are 4 physical interfaces, they behave as a single interface. The answer is, D switch 1 will only receive 1 copy. This Ether channel makes these 4 physical interfaces a single logical interface. A switch 1 won't send 4 copies of the same broadcast frame out of a single interface. Traffic using the Ether channel will be load balanced among the physical interfaces in the group. An algorithm is used to determine which traffic will use which physical interface. I will give you more details on this later. So D switch 1 received the broadcast frame. What will it do now? It will flood the broadcast frame out of all interfaces, except the one it was received on. So let's say D switch 1 has these 2 other links here. Which interfaces will D switch 1 forward the frame out of? Only these 2. Why didn't it forward the frame out of the other 3 interfaces in the Ether channel? I'll repeat it once more. Although this Ether channel contains 4 separate physical interfaces, they behave as a single interface. D switch 1 won't send the broadcast frame back out of the same interface it was received on. So it isn't forwarded back to A switch 1, and no layer 2 loop is formed. It's kind of like this. Instead of 4 separate interfaces, perhaps gigabit Ethernet interfaces, connecting A switch 1 to D switch 1, it's as if there is a single 4 gigabit Ethernet interface. The bandwidth of the 4 separate interfaces is combined to form one faster interface, a virtual 4 gigabit interface. The difference between the physical characteristics and the logical characteristics For example, we studied VLANs. Multiple PCs can all be connected to the same switch, and therefore be in the same LAN. However, VLANs virtually divide these PCs into separate virtual LANs. These interfaces exist as 4 separate physical interfaces, but now they form a single virtual interface. Some other names for an Ether channel are a link channel and a lag, which stands for link aggregation. Now let's take a look at how Ether channel load balances. It load balances based on flows. What is a flow? A flow is a By the way, you usually won't see a server or a printer connected directly.